Hello everyone and welcome to the metals track of DELMIA Operations World Tour 2020. My name is Prashanth Mysore. I'm a strategy and marketing director for DELMIA brand and I'll be moderating today's virtual event. Before we get started, I'd like to go over a few items so you know how to participate in today's session. If you've joined the event using the computer speakers, please make sure that they are turned on and up for optimal audio. You'll have the opportunity to submit questions to the team by typing your questions in the question panel of the control panel. You may send your questions at any time. We'll collect them during the session and address them during the Q&A session at the end of the presentation. I'd now like to introduce you to today's presenters. The session will be led by Thomas Brand, Vice President Energy and Materials Industry for Dassault Systems. He would start with industry vision and trends, followed up with innovation topic operations excellence by myself, and I'll be supported by my colleague Koert Munnich, with planning and optimization as a part of operations excellence. We'll also have an interesting customer case study by Slovenian Steel Group with eminent speakers Zdravko Smolej, Head of IT Automation, and Sonja, Kralj, IT Project Management Officer, sharing their value perspective of DELMIA planning and optimization. Let's kick off the session with industry and vision presentation for metals from Thomas Brand, Vice President Energy and Materials Industry. Over to you, Thomas.
So hello and welcome to this introductory session on sustainable metallurgy. My name is Thomas Brand and I'm leading the energy and materials industry at Dassault Systems. What I would like to cover today in these presentations are options that exist for today and tomorrow to improve sustainability of the metallurgy. So first, I wanted to start with a view of the paradigm that is changing around metals demand. That's a very, very high level view. However, it is a very important one. Across the last 2 centuries, there was a certain paradigm around energy and materials, which was to produce energy by extracting and burning hydrocarbons in the atmosphere. Basically, today, 85% of the world's energy is produced by burning hydrocarbons, either coal or petroleum or natural gas. And to produce materials, the idea was to extract materials, either hydrocarbons for the chemical industry or other metals and minerals, to use them more or less once, sometimes twice, and basically to dump them. They become waste either on land or in the sea. That has been the paradigm until now. And now we are heading towards something radically different, which means that decarbonization of the energy sector will rely on energy conversion devices that are manufactured primarily out of metals and minerals, which means that during this transition, decarbonizing the energy sector, we'll have to build more and more of those energy conversion devices, be it wind turbine, solar panels, nuclear power plants, or hydropower equipment and dams. So this means that during a transition, which will last for this century, there will be an increasing need for metals and minerals just for the purpose of creating those energy generation devices. And on top of that, there is the continued demand of metals and minerals for the usage that was already existing. In order for this to become sustainable, we have to make sure that all this extraction of metals and minerals is not once through, but really becomes circular. So that's the major paradigm change. Of course, within this circularity, there will be some losses, both for hydrocarbons and for metals and minerals, and we'll need to top this up with extraction, which will become minimal. So what does that mean for the metals industry? It means that metals industry is going to transform towards a circular industry. That is a very important point. The second paradigm change is that we've been in a commodity industry in energy and materials over the 19th and 20th century, and this is changing, and the industry is moving into productization. Productization of the end product, moving from bulk to specialty product, and also productization of the production infrastructure, moving from one-of-a-kind mega projects into replicable modular projects. That is another very important change. So overall, what does that mean? We understand that there will be a very strong demand for metals, be it due to the continued growth of the population, continued growth of the world's average GDP. But beyond that, beyond this continued strong demand, there will be a growth in scrap availability, scrap metal, many different types of metals, and I will go through some examples. And this means that this scrap metal availability, which is primarily going to be obsolete scrap, is going to start to fuel this circularity loop. And this means that the entire metals industry is going to shift again from a once-through industry to a real circular one. That is a major change. And here you can see some figures about the evolution of scrap availability, depending on the type of scrap and also the regions of the world. I think this is very telling. So it's happening today, okay? In the steel industry, for example, there is a very strong growth in electric arc furnace steel making, which has very strong environmental advantages. And this is developing extremely quickly, in particular in Asia. Beyond traditional metallurgy, we also have the new kinds of metals, energy metals in particular. Lithium is an example. Everyone talks about lithium today. Everyone wonders about how sustainable lithium extraction and processing will be. Today, already, lithium circularity starts to be organized. There's a number of companies in the chemical and metallurgical world that are going in the direction of lithium recycling. Why so? Very simply, because it's more economical to recycle lithium, particularly when it comes from electric vehicle batteries, because it is very much concentrated. Indeed, thinking about recycling metals from an electric vehicle battery is much easier than recycling it from smartwatch batteries. It's much more concentrated, and this is why major producers of electric vehicle batteries are today setting up their own lithium and other metals recycling plants. And one of the high-profile announcements from Tesla is that they are commissioning their first recycling line in the Tesla Gigafactory. So not only they produce new batteries from new materials, but they also start the circularity loop. This is very important because this is going to impact even more the manufacturing world. So one of the first points to make sure that the metals industry goes towards better circularity is first better sourcing. Indeed, it is extremely important to ensure that there is a traceability of the feedstock of whatever reaches the plants, and this becomes a reality today. A number of companies are positioning themselves in the field of end-to-end traceability. So traceability of raw materials, traceability of the processes that are used to transform them and to bring them to the metallurgical plant. So there has been a number of news recently around this. And what is extremely important related to this topic is that it's not the topic of one specialist doing something specialized at one stage of the life cycle of the metals. It's really an end-to-end process that brings a number of different disciplines together. And this is really a topic where platforms can play a very important role. So here, I think this very first step is a critical one. Beyond sourcing, which somehow is inbound, there are several other options that we have to discuss, and many of them are available today. So these options basically revolve around designing better products and also better processes. As I mentioned earlier, products are likely to become more and more specialty products, and we are moving away from bulk production only. And moving away from bulk production means that production companies can better control their sales prices and therefore their margins. Okay, it's really gaining more control over the top line and not only on the bottom line, which is typically the case with bulk commodities production. So investing in research and development and in order to develop better products with a high performance and design for specific applications means that a number of steps have to be undertaken. First, designing the new type of products, designing the new molecules, the new alloys, is an initial step that can these days be performed entirely in the virtual world. And design is not the only thing, it's tightly coupled with a simulation. Today, thanks to the development of high-performance computing and materials simulation, modeling and simulation, it becomes possible to perform all these steps in the virtual world. This is extremely important because it avoids many steps that can last for a long time and incur very high investment in the real world. So beyond those design and simulation steps, there is the step where once the molecule has been identified as the most promising one, and there is a step where you need to formulate the alloy. And this formulation will lead to, in turn, to the recipe development. How? Very close to what is being done in specialty chemicals, by the way. How am I going to produce and scale up the production of this specialty alloy or specialty product? This is a very important step because there is a major difference between being able to achieve results at a lab scale and being able to ramp up at a higher level. Of course, then all the ramp up and industrialization is something that exists and that needs to be connected to the earlier stages. Why so? Because during manufacturing, during the early stages or during a plant recommissioning or plant upgrade, one needs to be able to loop back to any of the previous steps to fine-tune, to recalibrate the simulation models, to adapt the formulation or even the recipes. And what is also very important in order to be faster in terms of innovation cycle and time to market is to have end-to-end continuity for all the workflows that needs to be digitized, as well as the understanding the inventories, and all of this applied from laboratories to fabrication. So this is extremely important, and all of this does exist today. These are options for today, and indeed Dassault Systèmes has a track record in this field that will be covered at a later stage in this session. So what is the benefit of having an end-to-end digital continuity around all of this? It means first, more safety, okay? This is of utmost importance, both at the industrial stage, but also at the end usage stage, ensuring that the specialty product that is being used complies with the initial requirement. So compliance is a major topic also. Being able to produce a specialty product in one country or another one, or producing it and exporting it to one country or another one, means that compliance should be at the heart of the industrial chain. And benefiting from such a digital chain ensures that compliance is extremely automated. Intellectual property control is also very important. Indeed, going through such an innovation chain is not always done in the same company. Sometimes it's about partnering with a number of players in the ecosystem, and each party has to have the control over its intellectual property. So again, an end-to-end digitized chain can ensure a better collaboration through a better information control. It may sound counterintuitive, however, there is no strong collaboration without strong information control. And in the end, such an end-to-end chain means a better agility in innovation. And again, it's not only innovation in the products themselves, but also in the production processes, which needs to change to be more sustainable and to cope with different varying market demand. Beyond designing the new products and the new processes, there is a need to produce better and produce more sustainably. Here again, there's a number of options that I wanted to briefly cover today. They will be covered more in details later, but those options are applicable today. The first one is about blending optimization. Inbound material can be of varying quality, and there is a need to optimize the way they are blended. And optimizing further the blending allows to use a number of different qualities of inbound material, which sometimes can be more local. And this has a strong impact on sustainability and on relocalization of the supply chain. So this is an important option, and blending optimization has to be looked at through this angle as well. Another important point related to sustainability is to optimize the scrap reduction. This can be done typically through a better order combination, and ideally separating clean scrap from dirty one. For example, in the aluminium industry, means that the clean scrap does not need to be recycled and can be put back in the process directly, which results in reduced energy consumption and emissions and avoids complex recycling loops. So again, direct reuse and scrap reductions through order combinations is a very powerful instrument in order to improve the sustainability of the production process. Going to another example in the steel industry, for those plants that combine steel making and rolling, there is a very powerful option which is related to hot charging, where basically we optimize the combination of the different production sequences to ensure that what comes out of the steel making process is not left to cool down, does not need any reheating, and goes directly into rolling. So this is an extremely sophisticated planning puzzle beyond what's available inbound, beyond what's requested by customers and the availability of the different steel making and rolling lines. However, being able to optimize the hot charging has a tremendous impact in terms of energy consumption, and avoiding reheating is a major source of economy also in terms of production. Finally, extremely downstream in the production process, there is another option to optimize the overall sustainability of the production process. It's to optimize the logistics. That may sound obvious, however, it is again an extremely powerful tool, especially now that end customers are measuring the end-to-end life cycle footprint of the materials they are consuming. They will take into account also the logistics part of it. So optimizing logistics, of course, reduces emissions and also optimizes the fleet or infrastructure usage. So optimizing the fleet means with the same number of trucks delivering an increased amount of material, or in case of rail freight, it can mean using single track dispatch system. We've seen in the past some of our customers who had saturated their train track and were considering financing the construction of a second track. And by just going into extremely deep optimization of the train schedule, it's been possible to almost double the logistics, outbound logistics, without the need for building such a second track. So again, the same applies for sea freight, etc. And what is important, again, is that all of these downstream emissions are now taken into account to calculate the footprint of the products delivered to the end customer. So again, a number of options available today: blending optimization, scrap reduction, hot charging, and logistics optimization. To go beyond that, it's not only about designing better products and processes and optimizing the production, it's also about ensuring that circularity can become a reality. So going into specialty products, it may be counterintuitive, but specialty products sometimes go against better circularity. Why so? Because these specialty products are first and foremost designed as performance products. And performance products incur extremely specialized types of fabrication processes, and at the end of their life cycle, it may be complex to separate the different components to inject them back in a new circularity loop. So better circularity means that what I highlighted in terms of designing better products and production processes means that materials design needs to take into account not only materials performance, but also their performance in light of a circularity loop. How are we going to break them down into elementary components that will be able to be injected in a circularity loop? Remember, we no longer talk about once recycling, but about multi-recycling. Multi-recycling is a very different concept because unlike what is being done today for most metals and alloys, multi-recycling will not work if we downgrade the usage of the metals or the alloys cycle after cycle, so that it ends up in very low added value material. Materials need to be able to be broken down into their elementary components. So this means leapfrogging in terms of materials design, and not only materials design, but also processes design. So developing new separation and production processes is going to be key. Beyond this design or redesign of the materials and the separation processes and the recycling processes, there is the need to organize, optimize, and execute the circularity loops. Effectively, that means collecting waste, scrap, wherever it is, in efficient manners. So again, this is a very complex planning puzzle, and it calls for broad optimization at multiple levels to optimize the footprint of the collection itself. So that's another logistics puzzle. Generally, we've been thinking for many years about logistics puzzles as one way from inbound to outbound. Now these are circularity logistics puzzle, and more as the recycling capability becomes more granular, it is important to organize those collection and circularity loops at a very granular level. So for example, again, small scale electric arc furnaces are booming everywhere, but they are small scale, and this means having very fine granularity in terms of optimizing the collection of waste metal in the close vicinity. So that's for the better circularity. And finally, we have other options to go beyond in terms of sustainable metallurgy. Of course, this is downstream in the value chain, but at the design stage, designing for circularity and design for recyclability, design for lightweight and optimized materials usage is an important topic. So there is a key metric which becomes more and more important today around the end product use. It's called the MIPS, material input per unit of service. When you take a look at two end products that deliver the same service, over the last few years, it's become common to look at the product that consumes less energy. More and more, it will become important to look at the product that uses less materials for the same service. So this is a challenge at the design stage. However, that can be helped by better design types of alloys to ensure a minimized use of material usage. But again, if this is a specialized type of alloy, it has to be designed with the idea that this alloy needs to be multi-recycled and therefore broken down into its elementary component. So that's at the design stage, so designing for circularity to reduce the material input per unit of service. And finally, there are other options, of course, at the manufacturing stage, and one of these is obvious and known by everyone today. It's the additive manufacturing. So additive manufacturing opens new ways to efficiently use metals, reducing the amount of scrap, ensuring novel ways of blending materials and metals in a progressive manner, and ensuring that production can be performed just in time. So these are options to go beyond, and I think that overall today we have seen a number of different topics that show us that we already have today started this journey toward circular economy, and that options to go in these directions do exist and are can be activated today. So in the follow-up of today's session, we'll first be able to deep dive into solutions that exist, and this will be a presentation by Prashanth Mysore. And after that, once the portfolio is better understood, we'll be able to go to a customer testimony with a Slovenian steel, which will share their experience in implementing some of those solutions. So that's it for me. Thank you very much. Have an excellent session for the rest of the day.
Thank you, Thomas, for your useful insights about the industry vision and strategy. The key takeaway from your session is definitely on sustainability. Thank you, Thomas.
Now, in this session, let's take a look at Dassault Systèmes 3D Experience Platform value to support operations excellence in metal industry for the digital transformation journey. I'll be joined by my colleague, Koert Munnich, who will also be sharing his experience in working with metal industry in planning and optimization domain. Before we deep dive into our solution experiences, let's briefly look at the business scenario in these strange time of disruptions. These are the top 5 trends happening during this disruption today, which are increasing operational flexibility, ensuring employee safety and security, either working remotely or working under safe conditions. And due to remote working or remote asset management, connectivity and cybersecurity is an important trend, along with resilient supply chain due to onshoring or nearshoring of manufacturing to reduce risk on critical supplies and definitely lowering costs to stay viable in the business. And I quote here, even the McKinsey report also talks about these emerging trends to support business continuity. Let's see what are the emerging digital transformation opportunities for metal industry to bring in flexibility, agility, and resiliency to their operations. The digital metal company, they're on a journey of big data, advanced analytics, and OPEX and CAPEX activities, which is data-driven raw material analytics to optimize feedstock cost, digital procurement strategies, and end-to-end supply chain integration, like production data sharing with suppliers, real-time supply tracking, predictive maintenance, advanced analytics-based predictive and risk-based maintenance across all aggregates, digital manufacturing, which is production automation, some of the examples like autonomous cranes for coil handling, robotics and automation, heavily contributing to total productivity improvement, digital integrated lean system like lean management, lean system to drive manufacturing excellence, industry 4.0, which is like industry renaissance, where automation is finding more widespread application both in production as well as in support functions. Let's see how these digital transformation trends can be achieved through 3D Experience platform. Let's see how 3D Experience platform supports these emerging trends and also opportunities for digital transformation through industry solution experience strategy. Based on our experience around the smart factory approach, we propose a solution around 10 steps to support operations excellence. These 10 steps are part of virtual twin experience strategy of collaborate, model, optimize, and perform. And these four are part of are a foundation stone for virtual twin experience strategy. Let's see in detail each of these steps to support various business processes. One of the important aspects to note is that most companies don't have the option of starting with greenfield factories and 3D digital renderings from architectural firm. But this is a very solvable situation, as the 3D experience platform has the tools, right tools necessary to build up the factory from any available 2D documentation. Or in this example, what you're seeing here, Dassault System partners with key technologies like mobile scanning, can scan the complete facility and bring in cloud of points. We can then convert this cloud of points into a 3D layout inside the 3D experience platform. This is the beginning of creating a virtual asset in 3D. The virtual twin can be used for downstream operational excellence activities. With the 3D virtual data available now, or virtual twin available, one can create capital facilities management using 3D experience platform. What you're seeing here, various asset management or asset repositories can be created with various documents, historical maintenance information, P&ID diagrams can be attached to this particular equipment for effective asset management here. 3D Experience platform provides a single source of trust for every stage of plant lifecycle, various equipment management, right from early design, engineering, production, and maintenance, and even operation. Knowledge is accessible across the various groups or various teams so that proper collaboration for effective production and maintenance management can happen using 3D Experience platform. With the virtual twin data and collaboration management infrastructure in place, let's now see in detail the activities of plant operation. I will request my colleague Koert Munnich to share his experiences. Koert, over to you, please.
Thank you, Prashanth. So let's have a brief look at our master production scheduling, or MPS solution. In the metal case, it is typically an order book planning system, or midterm planning, where we look at days ahead up until a number of months into the future, planning actual orders, but if available, also forecasts, as long as these are quite certain. It does this by planning all these orders and forecasts as late as possible, but as early as needed to be delivered on time, based on all the order details, the capacity of all the resources, the availability of materials, and the sales plan. The solution will take into account alternative resources, alternative routings, available semi-finished materials, etc. It can also take into account suppliers for raw materials, or even suppliers as alternative for own production. For instance, for doing a make or buy decision for slabs or for hot rolled coils. The goals and benefits of the solution are that it ensures that customer orders are planned according to delivery dates, as much as possible on time. It takes care of management of wandering bottlenecks. It tries to reduce the lead times without impacting the orders, leaving them on time. And finally, it increases supply chain visibility for the individual customer orders. So let's have a look at how it does that. The solution is high on optimization and consists of various building blocks that work together. It can be used to rebuild the whole plan anew every day and re-evaluate what is best for every order and every material that it knows. The planner that uses the system typically only makes changes in exceptional cases. The building blocks are sales plan check. Sales plan check takes care that orders are not planned as first come first served, but according to the agreed sales plan. Low added value orders should not be allowed to take capacity away from high added value orders without explicit planner decisions. Next to that, there is a combination of capacity planning, material replenishment, and material reservation, including make or buy decisions. And these 3 steps or 3 components are being used in one optimizer, in one combined optimization run. And this is taking optimization with the use of KPIs and makes a plan. The MPS solution also supports order promising during the day, every night, whatever is possible. And what it does is it uses the same optimizers to validate if new orders can be accepted, checking the capacity, checking the material, and also checking the sales plan. And at any time, there is full visibility of the plan. So the planner can analyze the resource capacity, the material plan, and also how orders are planned over the whole supply chain in the system. So until now, that's it for the MPS part. Let's move to from midterm planning to short-term scheduling. At the scheduling level, individual work orders and work order steps are assigned in a sequence to a resource, where the midterm planning worked as just in time, starting as late as possible. The scheduling solution will try to utilize the resource capacity as soon as possible, minimizing the idle times and gaps in the capacity. The goals and benefits of the detailed scheduling are to ensure that all orders are produced on time by making sure that all the operations are scheduled according to their due dates. It optimizes the task and work order assignments to maximize the utilization and the efficiency. It gives your planners the real-time insight to make sure that they can resolve their day of operations disruptions. The scheduler will also decrease waste by assigning the right materials to the right orders, minimizing scrap. And finally, it will decrease the work in progress by scheduling multiple steps ahead, using virtual materials. So also let's have a look on the details of that. Scheduling solution has the following building blocks. Resource sequencing, including sequencing of steps ahead with virtual materials, as mentioned before. Material reservation, which can also take into account relaxing criteria, allowing, for instance, overqualified material to be used, or even making sure that characteristics-based material reservation is done. It allows for batch creation and sequencing of the batches. For instance, for heat treatment furnaces, it allows campaign scheduling, and the optimization is supporting the planner, but the planner stays in control. He can always directly react on ad hoc incidents or events. And when he does that, he will see in real time, in a real-time overview, what happened and what is about to happen, allowing for manual intervention. And the consequences of all the actions of the planner and also the optimizer are immediately reflected in the KPIs, allowing the planner to see the quality of the actions in the bigger picture of the full schedule. This concludes a high-level overview of the planning and scheduling. And now back to you, Prashanth, for the next item.
Okay. Now with the virtual twin data as well as scheduling information available, we can leverage 3D Experience platform to simulate various factory processes. In this example, we are simulating the factory operations and validating the best industrial practices for crane operations here. We leverage 4D, which is 3D plus time, to optimally use resources like crane and ensure safety of maintenance operations, avoid collisions, and validate minimum distance for smooth operations. The idea of simulation here is to establish material flow or resource sequences, interactively create crane safety simulation, what if scenarios to help identify potential bottlenecks. We have the plant virtual twin model. We can leverage virtual reality and in some cases even augmented reality models to train the operators with standard operating procedure for safety. This is a natural extension of the plant virtual twin model for operators training, which we can help in eliminating risk and safety concerns, reducing training budget and providing scalability, repository of training knowledge, and validate worker interactions within the worker site to help to improve productivity. Now let's see an important aspect of IIoT in plant operations. This is where 3D Experience platform is a key differentiator in contextualizing IoT data with the model-based world. Using the operations experience, we can contextualize model-based and data-driven so that you can achieve virtual twin experience on 3D Experience platform. Let me run a simple example here. Steel plant operators or any owner operators will get access remotely to replica of an asset in 3D representation and also showing real-time data from sensors. You can see the real-time data coming from sensors using standard OPC protocols. This is the virtual twin experience I spoke about, which is nothing but monitoring the asset performance live. It's not only the monitoring, but you're also validating who's going to execute the work orders, which field resources and various operators. What asset has to be maintained and repaired based on the sensor data directly coming into the virtual world. Obviously, plant breakdown structure and bill of materials are closely associated with these actions. You can also see how to execute the work orders, where the assets are located in which plant and which unit, and what documents are needed to maintain and manage these assets, and when shall the work order be executed. So all of these actions are happening on 3D Experience platform, which is a unified environment supporting the business processes. Even the remote teams can operate and help the on-site teams in a safe conditions and in an efficient manner. And what you're seeing here is the data directly being read from sensors and stored in a PI system for subsequent asset management activities. Okay. Effective collaboration is an all-important activity for metal industry to achieve operational excellence. This is where lean operational management techniques based on simple user experience using touch panel screens comes in handy for organizational collaboration. You can manage shop floor meetings through lean collaboration techniques, capture and share knowledge, and one can take swift actions to overcome both plant as well as shop floor problems. You can assign tasks to various team members. So it's an intuitive and easy way to assign tasks. And you can also track the progress of these assigned tasks thanks to lean operational management, which is gaining momentum in various industry sectors. And we would strongly recommend or propose this technology for metal industry for shop floor operations for effective collaboration. The idea of lean operational management is to empower teams for their operational meetings, enable cross-functional teams to easily collaborate and drive continuous improvement, and you can exchange and share ideas and information seamlessly across multiple teams. With the lean collaboration infrastructure in place, we can see how manufacturing operations management, which is more than MES, which is manufacturing execution system, which can be used for effective production management in metals industry. Using manufacturing operations management, you can effectively execute, track and trace offline orders, even in remote or wireless environments. One can achieve improved operational visibility using manufacturing operations management, thanks to dynamic dashboards for informed decisions on production, quality, maintenance, labor management. Once the machine has been integrated to 3D Experience platform maintenance application, and through machine integrator, the data is collected from sensors on the machine, and the machine operating parameters are continuously captured via cellular wireless network into company's data lake. We can use configured application on this data and predictive analytics. And in this case, we have used a boosting algorithm to predict the next action. With this prediction process, maintenance and production managers can schedule a total productive maintenance action. Total productive maintenance are nothing but TPM actions. When doing so, it will not slow the factory's manufacturing processes, keeping production on track. The goal of predictive maintenance is to reduce maintenance cost and reduce downtime for repairs, increase production, and improve operator safety. Okay, with this, I would request Koert, my colleague, to walk you through some of the return on investment, and some customer action. Koert, over to you, please.
Yes. So where do we see most return on investment with our customers? First of all, in on-time delivery, where we regularly see two-digit improvements. Proper and well-integrated planning and execution will have a big impact on the OTIF, especially in the metals industry. Secondly, reduced inventory. It will give a one-time value for the metal, but it also has positive side effects, like the reduction of costs in storage capacity and more efficient material allocation, etc., which are recurring savings. Also, other costs can be reduced, such as waste or scrap, penalties for delays, for inbound logistics, but also for final delivery, and those can add up to from 5 to 20% in cost savings. And finally, reducing setup times and idle times will increase productivity. And there we see a typical percentage improvement of 3 to 5%. These numbers that you see are based on our experiences in metals market. And of course, certain customers gain more in one area, others in another. Every business operation has its planning puzzles. And DELMIA solves these planning puzzles and tries to optimize every operation for better performance and higher profitability. And it does so taking into account the full supply chain and all planning areas. Earlier we mentioned only a few, MPS and scheduling, but there are more. And our metals customers use different solutions. Our customers also vary from relatively small or local companies like Alwa in Argentina, Ulamin in South Africa, to big worldwide firms like Aleris/Novelis, Tata Steel, and ArcelorMittal. And they are located all over the world. In the bottom part you see a number of the names that we have as customers. So what did we bring to some of those customers? We tried to make some quantitative numbers that show what we achieved with our solutions in our customer base. So at Alinov, we reduced the stock of aluminum slabs and coils with about 33%. At Granges, formerly Sapa, we realized a 20% reduction of the work-in-progress material. Elval, an aluminum producer in Greece, was able to reduce their backlog with about 50% by using the DELMIA planning and scheduling solutions. At NetSteel, we improved their cycle times with about 30%. And ABS, a specialty steel producer in Italy, we allowed them to double their OTIF with our solution. And with this, I would like to move back to you, Prashanth. Thank you very much.
Thank you, Koert, for showing the benefits realized by our customers using DELMIA planning and optimization solution. Okay. With this, I'd like to reiterate the operations experience, which is a new approach to control global operations from integrated command and control centers, where 3D experience platform could be used to analyze overall equipment effectiveness of assets, identify the issues and then changes needed on those assets, and you can simulate and report issues of the deviation and assign it to stakeholders using those lean operations management techniques, which you have seen, which is intuitive, touch panel enabled collaborative management tool, wherein design, production, quality, maintenance, all the stakeholders can seamlessly collaborate to achieve operations excellence. Okay. So through various examples, you have seen how 3D Experience platform can help to address some of these operational challenges in a disruptive environment. Okay, we believe 3D Experience platform can be instrumental in ensuring business continuity, employee safety and security, manufacturing flexibility, and lowering short-term cost in any metal company. Okay. So with this, together with my colleague Koert, we'd like to thank you for joining this session. I hope you enjoyed the presentation. Thank you.
So now an all-important session from Slovenian Steel Group about their value realization using DELMIA planning and optimization tools. We would now invite Zdravko Smolej, Head of IT Automation, and Sonja Kralj, IT Project Management Officer, to share their experience of using DELMIA planning and optimization solution. over to you.
So we are coming from Slovenian steel group. This is the largest Slovenian steel producer and one of the largest stainless and special steel producer in Europe. So the company has 70% of market inside European Union. The rest is domestic market, something in the United States and a part on other countries all over the world. So the group is vertically organized. That means it covers all the processes from the scrap collecting over the steel production, direct distribution, also distribution over steel centers in Europe and also in the United States. There are two main steel producers in the group. One is in Metal Ravne. They mainly produce special tool steel, and the other is Akroni in Jesenice location. We produce rolled flat products, especially mostly the stainless quarto and the special steel quarto plates. So we are a niche producer. We have a big number of different products. So we were focused, let's say, on continuous improvement of our position on the market, and we were aware that we need some better support at the planning decisions. That's why we started with the planning project. So the main purpose or the main goal of the project was to improve the mid and short-term planning. Our planning process was at that time based on Excel sheets, and it was also based mostly on the resource capacity levels. So we wanted to convert this to the order-driven production. We also wanted to have better control over the resource utilization, especially bottlenecks. We wanted to keep them busy in all circumstances, even if, let's say, some unplanned stoppages occur in the all over the process. So we also wanted to let's say evaluate or to run our planning process by KPIs. So we set some goals for this to improve. The most important was to improve delivery performance, because it has also a huge impact when we are late to our penalties, to our costs. So when we start with this project, a lot of questions appeared and about what kind of system shall we use, because, like I said, we are a niche producer. Our diversity of products is very big, and we have a huge number of small orders. So we have a very complex planning puzzle. So we were asked ourselves, shall we keep this short-term daily scheduling system, which was let's say a part of customized solution inside the ERP system we introduced just a few years before. Shall we keep also the monthly sales and operational plan, which was done mostly manually, and we just let's say fill the gap between those horizons. Shall we let's say replace or implement everything in one step, from to cover all the horizons, or shall we just split this in different many steps? So what's the economy of the project? What is the return of investment? So how can we influence, let's say, to decrease the costs? So actually the question was, shall we implement also the internal partners, I mean the internal team and local partners? Because there is, besides, it's another benefit of owning solutions and to have better local support than later after going live. So when we tried to answer all these questions, there was a clear choice that DELMIA Quintic company planner product, let's say, is a proper choice for us. It's a good solution. So we were very confident when we have checked the reference list at that time, and we saw also the other world steel producers there. And we were convinced that also after we checked the capabilities and the features of the product, we were convinced that we can, let's say, satisfy majority of our needs using the standard industry solution, and just few customization might be needed.
Thank you. So what Zdravko was saying took about 2 years. So now the easy part came. So the implementation, it took us only 7 months. Me coming from the PMO, of course, one of the selection criteria when in the selection process, we were dealing with 5 vendors, was also how mature and well developed the project management methodology is. So how we can develop or implement the project is one thing, and how this is mapped to our internal project management methodology that's based on PMI. So it turned out that Quintic has a very well developed project management methodology. They also introduced the Express QPLC. So the difference between the normal QPLC is just that, of course, we had to be very faster, meaning that the honeymoon period ended sooner. So I see a few romantics here. This is where Quintic in the pre-sales phase, which I said took 2 years, maybe because we had to show them all the Slovenian touristic landscapes, gave an answer to the Quintic service account manager. Mattia, where are you? Oh, so he knows Slovenia now in and out. So we started with the implementation. So I can assure you that everybody who worked, probably you know that everywhere the Quintic has really mature PM methodology. So templates are there. So basically you focus just on the core. So you don't have to deal with any administration or something like that. So in a nutshell, we use the Express QPLC, and regarding the scope of the project, like Zdravko said, in the selection process, we mapped the standard, our processes, and the ability of the solution that can be best served with the standard. So Quintic was chosen, and this is also why we said that we are going to go with the out-of-the-box standard solution with minor modifications only if and when we have the full clarity of understanding before we modify anything. So we ended up with the industry solution of company planner with some minor modifications, which is what makes us successful, very successful at the end. This was proven to be. We stayed on the focus. You may know that the major risk and the major reason why IT projects fail is usually the scope creep. So people lose the focus, and this is what did not happen in our case, and this is the reason why we made it. Regarding resources, we also had a very, as we were told, we went with the approach that was tried for the first time. We had a combination of Quintic Q, so quality assurance people, so the best people from the Quintic side, the local partner and the internal team that were given. So our best personnel was given to the Quintic to manage that people. So this also turned out to be a very good decision, although risky at the beginning. The only thing that we changed is that the local partner, did not have enough business knowledge. So thank God we had Zdravko who took over that part, and this is what also made the project very successful. So my message is that not every partner can do, and Quintic projects are, besides the technical knowledge, they also require very deep business understanding and very deep business knowledge. Regarding the budget, we ended under budget, so this is the message. But it didn't look like that at the beginning. We also made a very good decision that, as I mentioned, we wanted to have the full clarity and the full understanding. So we invested a little bit more into training of the key personnel who then participated in the project. So we initially, from the beginning, we were over budget in the first month, of course, based on the plan. This was also very good because we saved money because it was pure time and material project. We saved money in the consequent phases. So the good news is that we had the money that we saved, we gave as a reward to our project team. So it was a win-win-win situation all over the place. So this is why it's a very positive project in our eyes, everywhere. Regarding the schedule, we were on a schedule maybe 2 weeks before the schedule. So, this was possible only because of these decisions that we made early on in the project. So the main task of a project management is that, of course, we have to identify the risks early on in the project, and then we have to manage them. So we prepared a very good mitigation plan, the contingency plan, early on in the project. The main risks the main challenges that we identified is, of course, organizational change management. I'm sure that you've heard that, so I'm glad that also our previous speakers said that we should not underestimate the organizational change management. This is usually a critical success factor, at least in our organization, where this is the most difficult part. So from the Excel-based planning to a sophisticated planning with one of the best planning tools, it was quite a challenge. So we had to make sure that also this organizational change management is addressed early on, and then, we should not, the focus and the full pressure should be on that we are not going to fail on that one. Mentioned before the project team, we had to make some very tough decisions. We had to replace some project team members early on in the project. So this was majority of the partner resources, and replace them with the internal resources. So we had a little bit of luck, because without Zdravko as an internal resource with the extensive, as a head of ID automation with extensive technical knowledge, he also understands business and the business processes better than the business themselves. So this was one of the also the key factors that made this project a success. Of course, Data in planning is like garbage in, garbage out. This was our major concern, and also we were warned about that from Quintic. With the Quintic, we had a very good team, we had a very honest relationship, and we were warned about all the pitfalls that can happen along the way. So we listened, and we prepared, and it turned out that at the end, the data was not an issue at all. A company planner is, of course, has to be integrated into overall IT architecture. Also, ours is quite complex, and this was also one of the critical success factors that we had to deal with.
Here below, you can see a few examples of our organization changes. The bigger one was this order acceptance process. Let's say we use now this monthly sales and operation plan as an input for a company planner for a sales budget. And now we, let's say, strictly respect these figures and orders or deliveries, let's say, promise date, confirm date. Now it's strictly defined by the company planner. So just let's say some exceptions are always allowed by let's say sales in some circumstances, then can override it. The next big restriction was also inside internal transportation, when we just simply don't allow anymore that the material, this intermediate material, is not transferred further if operation on it is not planned yet in the next period of time. Of course, few orders are still late every month. So when we update this confirmed date every month using the proposed date by company planner.
I mentioned that organizational change management was one of the major challenges and the task that we took very seriously. So from the initial project, so from the beginning of the project, we addressed the future processes. So what the future of using company planner is going to bring. So first we identified what is this going to mean, will this mean, and throughout the project. So my main task was to implement on how, so that it was via communication, so that everybody has a clear understanding. First, the management. So we gained the management support, the business owner support, to make sure that everybody understands what the future with company planner is going to bring. Who is going to do what, in which way. As you know, probably everybody understands that it's the easiest way is to go back to Excel. So we had to make sure this will not happen. And we were successful in that. Organizational change management is the process that we have, that is part of our every IT project. We also, now you probably understand that this was a very successful project that we delivered last year, and the best practices were incorporated also in our project management methodology. So we are taking this good experience, the positive experience from implementing such a complex project into everyday life. So number one is, of course, I'm going to refer to the experience that we have with the company planner, is that internal resources, you're always probably struggling with that, what is better. Our suggestion is that internal resources with the knowledge of the solution are absolutely necessary if you want to number one, maintain the level of usage on the required level, and of course to develop further and to improve the processes in terms of vertically or horizontally. Maybe one thing, so develop your internal resources. Zdravko and the colleagues Alex got certified. Believe me, Quintic does not give those certificates easily away. So this is quite a difficult experience also for the best people. This is we appreciated that. So we saw that Quintic is serious about what does it mean to be certified in the Quintic world. So the second thing that I said, not anybody can be a BC or a resource from Quintic because of the complexity. Usually what you have, because it requires people with extended business process knowledge. I think this is even more important than maybe the technical knowledge. We had a partner that was very technically capable but did not have a business process knowledge, and this is why we had to replace these resources with our internal ones. Regarding the expert group, we also Quintic because it was a very long pre-sales process. They also made sure that we got the best team also from their side. It was a very good, honest, open communication. Of course, every project has issues. We overcome those obstacles and issues in a very professional manner. So it was on a very high level of respect and understanding that we are on the same boat. We have the same goal, and this is the only way to go. Regarding the project management methodology, Quintic people were also very flexible. They gave us enough flexibility, so we found the right balance of, this is why we also think that the success was possible. And as I said, we did not allow any scope creep. Of course, there are always ideas when people see, the imagination kicks in, and everybody wants to have more. So in the project management and the core project team had to make sure that we stay focused, so that we understood what are the goals, and did not allow a lot of stories and additional requirements to kick in, unless they were well thought through or argumented.
Few words about data. So data was really not a big issue because we had a strong internal team who prepared the collection and loading plan, and we used the standard interface, database to database, and we use also these features inside the company planner, like data quality view, sanity check, let's say. So we were able to easily identify the issues. We track the status of solving these issues inside the Quintic project environment. Also, we track by the success or quality of the nightly optimizer run using or tracking KPIs we set. And so this really helped us a lot to integrate a solution into our system between ERP and our MES systems. So and just to mention a bootcamp training, at the beginning of the project, we organized internal bootcamp for the customer key users. So we always kept in mind that we are dealing with the standard solution. So we were focused to, let's say, to solve all the problems in our planning puzzle using this standard functionality.
Lessons learned, or maybe the key points or the key message that I would like to give you throughout this presentation is that based on this Quintic planner, company planner project was a success, and this was like a role model for all the improvements that we've made in the project, in also other IT project preparation, approval process, and of course the implementation itself. Number one, everything was of course valid also for the Quintic company planner project, is that there should be a clear business customer. This is valid for every project. So now in SAJ Group, on the total group level, we do not start up any project. Any project cannot even qualify if there is not a clear understanding who is the business customer, that we have a clear set goals and targets what needs to be achieved. So that this confusion that was maybe a practice before is now totally eliminated. Of course, the main part of the project is of course people that work on a project. So right people on with the right role, with the right responsibility, on the project. The scope also needs to be thoroughly checked. So we have a very thorough process of, first the business customer has to prepare the requirements, then everything is evaluated. So sometimes this looks like that, the longest part for the project is, and the most important part for us is the project preparation, because we understand that with the proper preparation, the probability of a project success increases drastically. Of course, how to implement the project. This is why I think it's very important when you're looking for a vendor that is the matching in the way how, in the culture, the way things are done, the understanding of the project success. This is also very important. I think we found a good match in the Quintic partner and the project methodology and the approach that we took in the implementation of itself. Of course, data quality, so garbage in, garbage out approach. We usually do the thorough homework also in the preparation phase. Does it make sense to go into complex project? Are we mature enough? Do we have do we understand what needs to be done? So are we ready? So this is very important. Maybe it looks like that we are really not risk takers. We take risks, of course, but if we can eliminate them, we don't engage knowingly in projects that are likely to fail.
Just to wrap up, so very soon after we went live last April, so we noticed that we have a big improvement of our KPIs, especially in delivery performance, and also we shorten time from the order booking down to finished good appearing on the final warehouse or up to the shipping. So we have also better overview or resource utilization, especially about the bottlenecks. And also thanks to the using different scenarios, we also improve our planning flexibility. So what's next? Of course, planning process is a live thing. So there is no such thing like a perfect plan. So there is always a room for improvement. And now our internal team, and of course together with the Quintic support, we are still, let's say, we will continue to work on it to improve and to fit the solution to fulfill all our needs. That's it. Thank you.
Thank you, Zdravko and Sonja, for an extremely useful insights about the value realized using DELMIA planning and optimization solution. It's indeed useful to all of us, and happy to note that you've indeed realized a lot of business value using planning and optimization solution. Thank you so much for presenting your session.